So in this video, I'm going to work through your test review from start to finish in hopes that you can find any problems that you're struggling with and prepare for your test tomorrow. So the first part, I'm actually going to show you how to do these problems with the calculator again, because that is really our expectation, is that you know how to use the calculator to solve these problems. So the first one involves a square root, and so we're going to hit this button right here to pull up our square root menu. I'm going to choose this one, which pops a square root up on my screen. Now I'm inside this little box, so whatever I type will be in there, and so I've typed my 3. I need to go back to that same menu to choose my exponent, and now for that exponent, I'm going to choose a 2. Now my cursor is still small, that means it's with the exponent, so I actually have to use my arrow tabs, these are your arrow tabs, to get outside of that exponent before typing subtract 5. Now I'm still underneath this square root symbol, so again, I'm going to use my arrow button to get outside the square root before typing divide 8. When you're finished with that, press enter, and your answer is 1/4. You can type 1/4, or you can change it into a decimal if that makes you more comfortable. To turn it into a decimal, you hit Control Enter, and it takes that same thing and puts it in decimal form. For number 2, the first thing I need to enter is a fraction. So I go back into that same menu and hit fraction. And now I need to enter the top of the fraction, which is 2 plus 3. And I'm going to put it in parentheses just so my problem looks exactly like what's on the paper. So I did my parentheses with these little buttons over here. And then I'm going to use my arrow buttons to move down to the bottom. And I'm going to open a parenthesis. I'm going to type -2, close my parenthesis, and I need that to be an exponent. So in my exponent, I want a squared. I'm going to use my arrows to get out of the square, out of the fraction. And then I press enter. And that answer gives me 5. My next question is 12 plus, now there's brackets there, but brackets act the same as a parenthesis. So as far as your calculator is concerned, you need to enter a parenthesis. And 20, open another parenthesis, 5 minus 1. Now close the 5 minus 1 parenthesis, but you also have to close the 20 times the 5 minus 1 parenthesis. So this parenthesis goes together, and that parenthesis goes together. Now that you're done, press enter, and you should come up with 92. Number 4 requires a fraction, so I'll go back into my menu and choose fraction. It also requires a square root. So now I've got a square root in the top of my fraction, which I want to type 7. That needs an exponent. So here's my exponent, squared, and I'm going to type down until I'm in that bottom box. And now I type 3 times 10. Use my arrows again to get out, press enter, and I should get 7/30. If you wanted that as a decimal, Control Enter, takes that problem and puts it as a decimal. Since this is repeating, I would highly recommend that you actually do this as a fraction. So that is the first 4 problems. Next, we're going to solve these equations, and then we'll talk about how to solve it, check your answer using the calculator. So for these next few problems, the first thing we need to do is combine like terms. So going through, I'm going to locate all my x's. I've got a -3x, a positive 4x. -3 and positive 4 gives me positive 1x. I have a -8, and that equals 17. From there, I need to get rid of the 8. To get rid of a -8, use a positive 8. And x equals, now 17 plus 8 is going to give me 25. As soon as I've solved all my problems, I'm going to go back and check them with my calculator. The next problem, I have k's on different sides. So I need to move the k to the other side. So I don't want to move the 7k because then when I do that, there's nothing left. And this confuses most people. So instead, I'm going to move my 4k over to the other side, because remember, the ultimate goal is to get all your variables on one side. 7k minus 4k is 3k, and that equals 18. And now all I have to do is divide by 3. So k equals 6. My next one, I have a 3 and a 4 on the same side of the equation. So 2a plus 7 equals 13. Now I need to subtract 7 from both sides, which gives me 2a equals 6. Divide both sides by 2, and a equals 3. For our last problem, minus 5, remember that does go with it, because if you add the opposite, that's really the same thing as a negative 5. So a minus 5 and a positive 2 gives me minus 3. I also have variables on both sides of the equation, so typically I like to move the negative 1 over to the positive 1. That way I cannot deal with the negatives anymore. And so then I need to get rid of this minus 4, which is going to give me 7 equals 5b. Now please remember that your steps may vary a little bit from what mine do, but you should still end up with the same end result as long as you've done it in the correct order. So divide by 5, and my answer is 7 over 5. Now next year, improper fractions are going to be okay, but I know that this year we've been encouraging you to change them. So you could also put 1 and 2/5, or you could even put the decimal, which is 1 and 4/10. So any of these answers would be okay with me. So now I'm going to pull up the calculator again, and I'm going to show you how to plug this information in. So the first thing to note is when plugging in equations into a calculator, it's actually a little bit easier if you just use x for all your variables. So the first problem was negative, remember to use the negative, 3x minus 8 plus 4x equals is over here, 17. Okay, so once you have typed in your equation, you're actually going to hit Control equal. And what that does is it brings up a little menu with greater than, less than symbols, but it also has this little bar that means such that. So once you press the such that bar, you can type what you think your answer is. So x equals, we said it was 25. And then press enter. And the calculator will tell you if it is true or not. So I'm going to do that one more time, and then you can go and check the other two on your own. So the next one was 7x equals 4k, which is x, plus 18. And we said we want to know such that x equals 6. And it said that was also true. So yes, you can definitely go through and check your other equations using this method, but we're just going to go with the answers that I put because I know they're right already. So on our next problem, it gets a little bit more complicated. It says the two triangles shown have the same perimeter. What is the value of x? Well, we know to find perimeter that we have to add up all the sides. So x plus 3 plus x plus 3 plus x plus 3. Now this is a pretty crazy long formula, so I need to do some simplifying. X, x, and x is 3x. 3, 3, and 3 is 9. Now it said that perimeter was the same as this perimeter. So again, I'm going to find the perimeter by adding them all up and simplifying. X, 2x, that means I'm at 3, and 4x, 3, negative 3 is nothing. So basically what I have now is this equation. How do I solve this equation? Well, I'm going to move my 3x to the other side, so it's with the other x's. and I've got 9 equal to x. So my answer is x equals 9. Now just a hint, I could go further with this, and I could actually ask you to figure out what the perimeter was. At this rate, if the perimeter of this one was 4x, and x is 9, you would plug it in to get the perimeter of 36. So just be aware of those types of variations. The next part, we are actually looking at graphing equations, and you can still use your calculator for this, but I'm not actually going to go through those functions on this video. So for this, remember we did talk about in the scavenger hunt how to plug in an equation and put it on a graph. You can do that. You can also plug in an equation and go back and look at the table. So I'm going to actually do it by hand, and I'm going to plug in -1 for x and 5. So this is -2 plus 5 is going to be 3. 2 times 0 is 0, plus 5 is 5. 2 times 2 is 4, plus 5 is 9. So now I have 3 points that I can actually graph: -1, positive 3, 0, 5, 2, 9, which this one goes off my graph a little bit. So what that means is that you're actually going to have to figure out what your changes are. So this is going up 2 into the right 1, so it should go up 2 into the right 1 for the next one. To continue the pattern going down, you would have to go down 2 in the other direction 1, down 2, other direction. And these aren't inequalities, they are equal. So yes, we're doing a solid line through that. You should have a ruler for this. I can't use one on the smartboard. And then we need to figure out whether it's a function or not. This is not proportional. However, that's not what I'm asking. I'm asking if it's a function. It's a straight line. So yes, it's going to be a function. Remember that a function means x's do not repeat. That's what you're looking for. So you definitely need to know the difference between those two situations. The next one's a little bit different. It's got this kind of funky thing here, which you saw in your quiz. So you need to be really careful. Whenever you do that, you need to plug your negative in a parenthesis. And then you need to plug it into your calculator to check, because this is the one that most of you had trouble with. This means -1 times -1, which is positive 1. A positive 1 minus 1 is 0. You can also plug this into your calculator to check the table and to check the graph. So if you're having trouble with that, you might want to go back and look at that scavenger hunt you did while everybody else was star testing. So this is 0 squared minus 1. That's 0 minus 1, which is -1. Then we have 1 squared minus 1. 1 squared is just 1, so minus 1 is 0. So I'm going to plot my points: -1, 0, 0, -1, and 1, 0. This actually is a little bit funky, but it's kind of like a weird curve like that. If you ever needed a few more points, go and plug them in. Say -2. Okay, this is going to be 4 minus 1, which is 3. So when I plugged in -2, I should have gotten 3. So if you're not sure what something's supposed to look like, figure out more points. 4 minus 1 is 3. So when I was at 2, I should have been at 4. See, my graph is a little bit off. You'll learn a lot more about these types of equations next year, but right now you should be able to plug in multiple points to figure it out, or you've got your calculator to help you there. So this is what my equation should have looked like. We don't worry about proportional or non-proportional unless we're talking about a straight line. So this is non-proportional because it's not a straight line. However, I asked you if it's a function. And in fact, yes, this is a function. While my y's repeat, my x's do not. So for every x value, there's only one y value coming out. So is this a function? Yes, it is. Next, we started talking about rate of change. And remember, our rate of change is always y over x. We're interested in what's happening up and down before we go left to right. So this is increasing by 1. This is by 2. I don't know that one. I don't know that one. This is increasing by 4, and this is by 12. So remember, we're looking at our ratios here of y to x. So that's 4 over 2, which simplifies to 2 over 1. So our rate of change is 2. So I should have a 2-to-1 ratio between everything. So this is your x, and this is your y. Notice that this x is a 1, which means keeping with the ratio, that should be a 2. However, this is a 12 for the y. I need to keep with this same ratio. So what does the x change have to be? 6, because 12 over 6 reduces to, simplifies to 2 over 1. So 3 plus 6 is 9. Now this one I've got to work backwards. Negative 2 minus 2, this one's going to be a negative 6. Please remember that this box right here is super important, because that tells you on your graph, at 0, I was at negative 6, which 1 means it's non-proportional. 2, it means that that's our starting point, which helps us with our equation. So our equation is y equals something x and then something else. The something that goes with the x is the rate of change. This is the rate that the variable is changing at. The variable is what changes, so the rate of change should go with what changes. And then the last part is the minus 6, our starting point. Remember when we were talking about proportional or non-proportional, we said that if something was added or subtracted from our equation, it was non-proportional, because what that did is made us not start at 0. All right, let's try another one. I'm going to erase a little bit of this. So I'm still looking at my rate of change, plus 1, plus 1, plus 1. This is, going down, minus 2. I don't know what's happening here, but if this is going up by 1 and that minus 2, this should be the same. So my rate of change is negative 2 over 1, which is negative 2. It's a little bit different than what we've looked at before, but it's okay. And I already gave you your starting point. So going down to, this is going to be minus 10. That fills in my chart. And then y equals, what goes with my x? My rate of change. What goes behind my x? My starting point. Excuse me. The next problem is a word problem. It says, Lindsay's monthly magazine subscription costs $1.25 per issue. So that means our issues are going to be represented by M. So it's $1.25 M. Kenzie's monthly subscription costs $1.50 per issue. So that is $1.50 M. But she's receiving her first two issues free. So we're going to be taking off 2 issues. Which equation could be used to find the number of months after which the girl will have paid the same amount? So in this case, and sorry, this is issue, she's getting 1 issue per month because it's a monthly magazine subscription. So that's why they used M, is because it's 1 issue per month. So we're going to do, Lindsay does not get anything free. So she's 1.25 M. That's how much it cost her. So A is out because it's lacking the M. However, sorry, I was looking for her name. Kenzie gets, it's $1.50 per month. However, she's not paying for all those months. She's doing the months, subtracting 2 that she gets for free. So it's $1.50 per all the issues she pays for, all the months she pays for. So say she gets it for 10 months, she's getting 2 of those for free. So what we should be looking for is this one. I know that's a little bit of a complicated situation, but I find it's really helpful to go through and read using the actual word instead of the variable to help you narrow down your answer choices. Nicole had $120. If she had $500 on week 19, how much is she saving each week, given that she saves the same amount each week? We're going to write an equation to represent the situation. Now, I did not give you a table on this, but I highly suggest that you create one. The input is the number of weeks. The output is how much she'll save, amount she has. So that's important to figure out what's going to be your X value and what's going to be your Y. Your X is always your input, which is the weeks, and your output is the amount saved. So at 0 weeks, we don't know, 1, 2, 3, 4, 5. Perfect. Okay, so on the 19th week, she had $500. She started with 120. That's why she said it said she had 120. So we want to know how much she must have been saving every week. She's saving the same amount each week. So if she started out with 500, take away what she originally started with. That gives her $380 that she saved over this time period. How many weeks is that? 19. So I'm going to divide that to come up with she must have been doing $20 a week. So that's 140, 160, 180, 200, 220, 240, 260, 280, 300, 320, 340, 360, 380, 400, 420, 440, 460, finally 480 to the 500. So it asked us to write an equation to represent the situation. Well, she's doing $20 per week. So that's our rate of change. So it goes with our variable. And we started at 120. So that 120 was our initial amount that we had, and then we're getting $20 per week in addition to that. So this is my equation. This one actually gives you the template that was similar to what was on your quiz and some homework assignments. It says Alexis is ordering materials to make homecoming mums. She charges $25 per mom, so that's going to be your rate of change, in addition to the decoration she puts on it. She charges the same amount for each decoration. Alexis charged $34 for a mum with 6 decorations on it. Use the following template to create a table, graph, and equation. So we need to figure out what our X and Y is. Our Y is going to be our total cost. And that's going to be determined by how many decorations we put on it. So we could put 0, and she charges $25, because that's just how much she charges for a mum. But 1, 2, 3, 4, 5, 6, which was $34, 7, 8, and 9 mums could be different. So to figure out the rate of change, I'm going to do 34 minus the $25. That's going to tell me 9. This is how much she spent on decorations. How many decorations did she have? 6. So when I divide that up amongst the decorations, each one's $1.50. So that means for one decoration it's $26.50, 28 for 2, $29.50, 31 for 4, $32.50, 34, $35.50, 37, $38.50. So my equation is going to be y equals, X is the part that's changing. So how much is it changing each time? $1.50 per decoration. And then it's added to the $25 she charges minimum for a month. So this relationship is going to be non-proportional because it will not start at 0. Okay. Also, there's something added or subtracted to the equation. So from here, at 0, we started out with $25, and then we went up a little bit, a little bit. Sorry, I'm trying to estimate. It's really hard on this little smartboard. So I'm just trying to go up the same amount every time. Oops, I think I've gone up too much. There we go. And so you get the idea. You guys will be able to do a little bit better on your paper because you've got a pencil that's a little bit smaller than this. But that is the general idea. So we always want to label our X and Y. This is our total cost. And this is our number of decorations. Okay? Labeling your graphs, always a good idea. So that covers the equations, writing equations, graphing equations parts. Now we're moving on to the inequalities. So on here, you always have to solve for the variable. So that's my first step. And remember, you solve these treating it almost like it's an equal sign, even though it's not really. Excuse me. So at this point, I need to divide by 2. And that gives me x is greater than or equal to 4. So that means 4 is my turning point. And so that's where I'm going to put my circle. This solid line tells me that it's going to be a shaded in circle because I can be equal to 4 as well. But I also have to be greater than. So you shade in the direction where all the numbers are greater than that. On the next one, I need to get rid of the -2. That gives me 3 is less than x. This is kind of written in the wrong direction, so I'm going to put x first. Notice how the big side of the sign is pointing towards the x? That means the big side of the sign needs to be pointing towards the x on this. In other words, the point points to the 3, so the point should point to the 3. I like writing it this way because it's a little easier to read. My turning point is going to be at a 3, and because it does not have the equal sign, it means it has to be an open circle. I can't color it in because x has to be greater than 3. That means I can do everything right up to 3, but not 3. So we use an open circle to notate that. So that's what your shading should look like. After 1 variable equations, we moved on to 2 variable equations. So the next question asks, which of the following is not a solution of the inequality? So here's the inequality. Notice that this one has a negative in front of it. And we haven't really taught you how to deal with that. So you definitely need to just plug it in. So 15 minus 3, that means 0 is going to be x. Is 15 minus 0 greater than or equal to 3? Yes. So that's not it. 15 minus 3 times 2 is greater than or equal to 3. That's 15 minus 6, which 15 minus 6 is 9. Is that true? Yes. 15 minus 3 times 4. This is going to be 15 minus 12, which is 3. That one is exactly equal, so it's still true. So this last one must be my answer. So 15 minus 15, that's 0. Is 0 greater than or equal to 3? No. So D is my answer here. Finally, we moved on to graphing on a coordinate plane. And remember that when we graph these, we treat them initially like it's an equal sign, which means we just need to create an XY table. I will usually use -1, 0, 1. And then we need to plug it in. So 1/2 times -1 plus 2. Well, that's -1/2 plus 2, which gives me positive 1/2. 1/2 times 0 plus 2 is 0 plus 2, which is just 2. 1/2 times 1 plus 2 is 1/2 plus 2, which is 2.5. So I'm going to plot my points. I've got -1, 1.5. I've got 0, 2. And I've got 1, 2.5. So what's happening is every time it goes up 1/2, it's going over 1. So I'm going to continue that pattern of going up 1/2 over 1 all the way to the edge of the graph. And if you use a straight edge, this actually helps you with your estimating as well. Now, much like what we were doing before, because this set is greater than or equal to, it means we can have a solid line. That's kind of like when we did the filled-in circle versus the open circle. And then the very last step is to choose a test point. I always choose 0, 0, if at all possible, because it's a very easy number to work with. So 0, 0 is right there. I'm going to plug it in and see if it works. So this is 0 is greater than, that's 0 plus 2. Is 0 greater than or equal to 2? No. That means that where 0, 0 is, I can't shade there. Which means if I can't shade below, I have to shade above. So there's not going to be anything down here, and I'm going to do all my shading above that line. That should kind of make sense because this said y is greater than that line. So here's your line. This is the part that's greater than it. The next one actually requires me to solve for y. So I'm going to get rid of the 6x, and that gives me y is greater than negative 6x plus 4. At this point, I can now make my xy table, negative 1, 0, 1. This is negative 6 times negative 1 plus 4. So negative 6 times negative 1 is positive 6, which 6 plus 4 gives me 10. Negative 6 times 0 is 0, plus 4 is 4. Negative 6 times 1 is negative 6, plus 4 is negative 2. And now I've got some points to graph. So negative 110 is going to be somewhere up there. It's off my graph. So 0, 4 is right there, and 1, negative 2 is right here. So you're going to have to rely on your rate of change here to be able to complete the rest of the graph. What I'm noticing is that I'm going down 1, 2, 3, 4, 5, 6 as I go over 1. So 1, 2, 3, 4, 5, 6 over 1. I've only got 3 points, so you definitely need a ruler on this one. Notice that there's no equal to, which is kind of like your open circle, except we're going to draw dashes in there. So again, ruler, very helpful. So this is our line, and we need to figure out whether to shade above it or below it. We do that by coming up with a test point. I'm going to choose 0, 0 again because it's easy to work with. So that's 6 times 0 plus 0 is greater than 4. That's 0, everything's 0. Is 0 greater than 4? No. So that means where that X is that I drew, I can't shade there. I have to shade on the other side of the line. So that's graphing inequalities with 2 variables. Now we're going to talk about some word problems with inequalities. This is exactly the same. It's just at the end you're going to need to decide which side needs to be greater, less than, equal to, etc. So when we look at this, it says Keith has $500 in his savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of summer. So we start with $500. We want to have at least $200. So $200 would be okay, but we've got to at least have that much. He withdraws, he's taking away, $25 each week. Which of the following inequalities represents this situation? So first of all, 500 adding money? No. 200 adding $25 a week is going to be I don't know about that one. It sounds a little funky. So we're going to look, this is a maybe. Let's look at G and J first of all. This says we have $500. We're taking away $25 a week. That sounds good. That's going to tell us what we have. We want that to be more or equal to the 200 because we want to have more money left or equal to the 200 at the end. So this one does say more, but it doesn't say equal. So this one's not going to be okay. This one down here has our 500 minus our $25 a week. So what this one says is that the money we have, and I'm going to switch this around so it makes more sense to me. See, I just pointy end, pointy end. So the money we have is less than or equal to 200. So that means the money we spent is less than or equal to the $200 we want to have left. So in other words, that means the $200 we have left is greater than or equal to what's in our account, what we spent. To me, that one sounds right, even though I know it's a little bit weird. This one says the money we have left, the money we want to have, plus the money we spent should be greater than or equal to 500. You can't have what you spent and what you have left be greater than what you started with in the first place. So that one is why that one's out. The next one, yellow cab taxi charges a $1.75 flat rate. That means it's just going to be added at the end. And it's 65 cents per mile. So I already know that I'm looking for this part, which means I'm going to go and get rid of anything that has subtraction. Unfortunately, none of it does. So now we need to figure out, she wants to spend no more than $10. So this says what she spends has to be less than or equal to 10. This one says what she spends needs to be greater than or equal to 10. She can't spend more than she has. What she spends has to be less than 10. We could spend no more than. Could we spend $10? Sure. So this one's wrong because it doesn't have that equal there. This one says what she spends has to be greater than or equal to $10. So again, these two are almost exactly the same, which are not correct because you can't spend more than you have. So F is our answer there. So this is the end of the review. Please make sure, in addition to studying this, that you look back at all the assignments that we've done throughout the week. They are very, very good reviews for this, as well as your quiz last Friday. And good luck studying.